Hello, Minglawa, everybody. So, welcome back to Clitop Engineering Open Lectures. So, for those of you who are joining us for the first time, we are just offering open lectures in mechanics. And the reason we try to select mechanics as the open lectures because it's an important topic in engineering and science students, and as well as those of you who are preparing to sit A Level exam. So, in the previous videos, we have show you how to derive the equation to find the acceleration due to gravity, which is the value of g. And in this video, we will just have a kind of practical experiment demonstration so that you can do the same experiment yourself to get the value of g using the theory that we have learned in the previous video. So for those of you who have not watched the previous video, I advise you to watch the video first before you watch this video. So now I will try to show you to get the software for this purpose first, and then later I will just demonstrate the measurement of g from the experiment directly. Right. So now let's just start with the software. So yeah, so if you look at this website on my screen, so you will see here physless.org/tracker. So this is the open source software from Open Source Physics, OPS. So this software is called tracker software. So we use this software to track the video of the particle or object moving. And now, of course, you have to take the video first before you can analyze using the tracker software. So you can just get a copy of this, I think, by here Windows 64-bit version. Right. So you just get a copy of the software and install on your computer, and you can also get some of the video, which are really good. So for example, if you look at, there are some videos, they have mechanics videos .zip file, so you can just download it, and there are different kinds of motion that you can use to analyze the kinematics of the particle, and then you will have better understanding of course particle kinematics. So in fact, we will use one of the video from that mechanics videos in our particular demonstration. So just get a copy and then just get the videos there, and then you can just easily follow with my lecture, and then you can measure the acceleration due to gravity. Right. So now let's just start the particular demonstration. So this is the tracker software that we have just downloaded and installed for you. Install by us. So now the first step that you will do is you will just import the video that you have just downloaded. So select the ball drop video from the mechanics video that you have just downloaded, and then the video will be loaded here. So you will see the video here, and now the first step is importing the video, and after this the second step is you have to analyze the video so that you are trying to cut the portion that you want to analyze. Right, the video can be in fact longer, but you are trying to limit the frames that you are interested in only. So in our case, we just would like to analyze the free falling motion. So that is the reason we were trying to look at the video frames by frames, and then we were just trying to mark in and mark out at the frames where we see the free falling motion only. So if you want to do that, you can just forward here. There's step forward using this arrow. So let's try to look at that. Now if you look at the video, and now the ball start to draw, in fact you can see here. So that is exactly the frame where we want to start. Right. So now you see the ball starts to drop. So this is the framing that we are interested in. And now if you look at the frame number is 3. So we will start from frame number 3, and then we will just look at further where the object passed through the lowest mark in our video. So here, so this is just enough, and this is frame 17. So we are interested in analyzing the video from frame 3 to 17, and now we will try to mark in a markup for those frames. If you want to do it, you will just go to the clip icons here. So you just click the clip settings, and then the start frame you just key in 3, and the end frame you just key in 17. And after you've done it, you will see here there will be 2 arrows mark in and mark out. So this is the start frame at frame 3, and this is the stop frame at frame 17. And now I will just tell you one more time. To mark in and mark out, you will just go to the clip of film button here, and then you press it, and then the windows will pop up, and then it will start to ask the start frame and the end frame. You just put 3 and 17 there. So now we have already got the portion of the videos that we are interested in. And now after that, since the video where the software will analyze the motion, the displacement, the velocity, everything based on the known measurement or dimension, so you have to put the calibration stick there. In order to put that, you go to the calibration stick and then go to new and take the calibration stick there. So if you look at this again, it's just perfect order. So you start with the clip settings, and then the next button is the calibration. So you just go to new calibration, and then the calibration stick appear. And in that video, the dimension from the top mark here to the bottom mark here is just 1 meter. So this is exactly the calibration that we will do. So you will try to adjust the stick so that the start of the stick is at this mark in the top, and the second end of the stick at the mark at the bottom line here, and then you key in the dimension 1 meter. Here is 1 meter already. And of course, if you take your own videos, you can just put some object whose dimension you know it, and then in the video you just in the software analyze it, you just take the calibration button, and then you just can start keying in and adjust the length and keying in the actual dimension of the object that you have outside. And then after you do it, Trigger will of course able to calculate the displacement of the ball based on the calibration stick, right? So now you have the calibration stick, and now you have the video number of frames that you are interested in. And now the next step is the coordinate system. So you can add the coordinate system by clicking the next button, which is just this. And of course, for every motion problem you need the coordinate system. So just to match with our theory, so we will just put the coordinate system 0 at the bottom line here. So this is 0, and of course the height. Now the particle is 1 meter height from the coordinate 0 position. So now you are almost ready, and the next step is just to track the particle. So you can just track it. So you just press the track button, and then new, and you just select point mass, right? And now you just press the shift key, and then the particle track button will appear. So what you do is you just follow the movement of particle, and then click the particle at every time step. So now you see particle moves, and I click, and you have to hold the shift key. So you just follow the particle. Alright, so just keep on pressing the shift button, and then you click the position of the particle. Alright, yes, okay, so this is the last position. Now you can see the particle in motion diagram, the trace of the particle at different time step. And as we have learned in the theory, because it's constant acceleration, so the object is speeding up, accelerating. So that is the reason. If you look at the displacement or the distance in each time step, the distance is higher because your object is attaining the speed. So the speed is increasing, right? So that is the way you track the object in tracker software. And after you track it, tracker will show you the graph here. So if you look at the graph, the first graph is just displacement and time graph, and the x-axis is time and the y-axis is displacement in x direction. And of course, in our motion, we don't have any displacement in x, but of course, theoretically no. But practically, we may have some movement in the x direction, but they are very small. If you look at that, our object is just on the left side of the origin, so that is the reason the value of x is minus here. So it starts with minus 215, and now if the object is strictly falling vertically, there will be no x displacement. But of course, practically from the experiment, you can see there are some variation, but there is not very much, because the x displacement just varies between minus 0.215 and 0.225. So we can just neglect infer. So, and that is the reason we will just see the y displacement. So I will just change the first graph to displacement in y direction at the time. So if you want to change that, you just click the label in the y-axis, and then you just select position y. So this is the displacement in y. Now if you look at it, the object at time t is equal to 0 is 1 meter, and then object start to fall, and you will see around 0 time is equal to 0.46, the object hit the ground, which is just 0. Right, so this is the displacement of time graph, and we can also get the velocity of time graph. So in the second graph, we will just select the velocity y, v1 here. Again, if you want to get the velocity, if you want to change the y variable, you just click the label, and then you will just select velocity y. Right, so if you look at the velocity y, because it's constant acceleration, we expect the gradient or slope of the velocity time graph to be straight, and you can see here the line is almost straight. And of course, in the actual experiment, this may not be complete straight line, but at least it's very close to the straight line, so the motion is quite okay. So now if you look at this, so since the object is just falling vertically downward, so you can see the velocity is just minus. It started from 0 initially. You can see here, because it started from 0, minus 1, minus 2. So at time t is equal to 0, initial velocity u is 0, and final velocity around 4.04 at time t equal to, if you want to look at the exact number, you can see the table below. So under the two graphs, you will have the table showing the time, the x displacement, y displacement. And again, you can select what kind of quantities that you would like to display. So if you want to change that, you just click the columns here. Now I will just select the y direction displacement and vy. Right, and now you can see here y is 0, so which is just minus 0.0025. So e to the power minus 2 here just show 10 to the power minus 2. So this means the number is like 0.02 meter, minus 0.02 meter, so which is almost 0. So at time t is equal to 0.468, you have your object passing through the reference point, so which is just 0 height, right? And your object started from 1 meter exactly, so you can see here 1 meter at time t is equal to 0, right? And the velocity at the time, you can see here minus 4.035 at 0.435 seconds, right? So, and now this is the way we try to get the number from the experiment, right? So let's try to write down the number for our calculation purpose. Excuse me, yeah. So I'm just ensuring my inks are working, so that's good. So at time t equal to 0, u is equal to 0, and the initial y is just 1 meter. Right. So this means your height is 1 meter. And now the time taken to pass 0 from this is, we have just seen it, and you can see again if you want. So 0.468, and it is 0 here, right? So time t is equal to 0.468 second. The height y is minus 0.025 meter. Of course, not 0 exactly, but I think that's fine because it's quite close to 0, right? And now our first purpose is to get the value of g from this experiment. And now based on our derivation in the previous video, we have already calculated g equals to, the formula is 2h by t squared. Right, and now all we need to do is just substitute the value of the height is 1 meter and the time is 0.468 squared. Right, and now you just have to, so g equals to 2 times 1 meter divided by 0.468 squared. And now all you need to do is you just work out the number. So I will just open my calculator and work out the numbers. So 2 times 1 divided by 0.468 square is 9.13. So my g here is 9.13. So there's some error in fact, and of course that may be caused by the time here, because this is minus something, but we have to take the time at when the object passes to exactly 0. But never mind, I think there's at least close enough. Of course the exact value from the literature is just 9.8, so we can calculate the error. So let's say we're going to calculate error percent. It will be just 9.13 minus 9.8 divided by 9.8. So this is the error percent times 100. How much is our error, right? So again, I will just use the calculator to get the number. So 9.13 minus 9.8, 9.13 minus 9.81 divided by 9.81, and so I will get minus 6.93%. Right. So the error is minus 6.93%. So you can see here, and of course we have some error. Possibly the error is in fact possibly caused by the fact that we don't exactly take the time when it passes to 0, and also there are some movement in the acceleration, right? But of course this error 6.93% is quite large, because we know acceleration due to gravity is around 9.8 meter per second square. So somehow there are some error, but at least I hope you will have the sense of how to measure g from the experiment. And of course another possible reason that the error is, we have the error in this experiment, maybe the delay in the delay of the recording device, because when the recording device capture the movement, because of the delay and the sensor and the maybe measuring circuit, we will have some time lag between accurate drop and the one recorded. So that's also one of the possible reasons, right? So yeah, you can try this experiment by yourself and to get the value of G. And now let's look at the velocity. So if you look at the velocity, U is equal to final velocity V is equal to U plus GT. Now the value of G that we have is just minus 9.1. So U is 0. The value of G is minus 9.1 that we have got it meter per second square, and the time is like 0.468 t. And now you can calculate the final velocity V from that equation. So if you look at the final velocity V, we will have 9.1 times 0. Let me check the number again. 468. So the velocity will be around 4.26. So we got the velocity minus 4.26 meter per second, right? And now from the tracker, you can see here the velocity is minus 4.037. Again, it's a little bit different, and the reason, of course, is tracker software, because it's just based on some specific computing technology to get the velocity V, and they cannot somehow get the velocity at time t is equal to 0.468 seconds. But at time t is equal to 0.435 seconds, the velocity is minus 4.037, right, which is quite close in first. The one estimated is just minus 4.26 meter per second, right? So I hope these two demonstration of how to get the value of G from the simple free falling motion of the object, and also of course the verification of the final velocity V is equal to U plus GT from the particle kinematics theory would help you understand better about the particle kinematics, right? So now just to sum up, we have demonstrated you easy and quick way to measure the gravitational acceleration by using the equation G is equal to 2h by t square and open source software tracker. And we also demonstrated how to verify the velocity equation in the constant acceleration V is equal to U plus AT. I hope you get some skills from watching this video, and then you can just repeat your own measurements using the software. So what I advise you is you just take the video of the particle falling freely using your mobile phone camera, and of course you should have some item whose dimension is not like a ruler or measuring tape on the wall, and then you try to get them in the video that will be used for the calibration purpose. And after you take the video, you just import your video in the tracker software and follow the procedures that I have just demonstrated, and you can come up with the value of G by your own experiment analysis, and also of course the verification of the velocity in the free falling motion. So if you're interested in, just do this experiment and let us know the finding. We are really interested in discussing with you what are the possible errors, and are you getting more accurate result than us. So those kind of things, or other new idea that you may have in your mind after doing this experiment. So we really look forward to see your results and getting your comments on that. So please do it, and of course stay tuned and subscribe to our channel to see the next video. Bye bye.